Good morning to all. This is Anvesh from AAA branch. So today my topic is about the incidence matrix and the bus incidence matrix. So of a subject called power system analysis. So basically, first of all, before learning the bus incidence matrix and incidence matrix, we have to know about the network topology. What is mean by network topology? So the network topology is one of the technique to solve electrical networks consisting of number of OG mesh or the number of nodes where it is difficult to apply the mesh and nodal analysis. Graph theory is the technique where all the elements of the network are represented by the straight lines, irrespective of their behavior. Here, the matrix methods are used to solve the complex networks before seeing the actual matrices. The knowledge of some of the definitions is very important. So basically the network topology is one of the technique that which is used to solve the electrical network consisting of number of OG meshes or nodes. So we can call it as mesh analysis or nodal analysis, where it is very difficult to apply the mesh and nodal analysis. The graph theory is a technique where all the elements of the network are represented by the straight lines irrespective of their behaviors. Here, the matrix methods are used to solve the complex networks before seeing the actual matrices. So, the knowledge of some of the definitions is very important. So, basically, what is mean by incidence matrix? It is represented by the letter. So, the incidence matrix is formed between the number of nodes and number of branches. This matrix is very useful, easy understanding of network, and any complex networks can be easily fed into the system for coding, or of any incidence matrix is n into b. So procedure to the incidence matrix is a of ij equal to 1. If the jth branch is incidence to the ith node and the direction is away from the node, and the aij is equal to -1 if the jth branch is incident to the ith node and the direction towards the node. So if aij is equal to 0, if the jth branch is not incidence to ith node, so it is 0. So it is 1 when the branch incidence is to the ith node and the direction is away from the node, and it is -1 if the branch is incidence to the ith node and the direction towards is from node, and it is 0 if the jth branch is not incidence to the ith node. And next, the properties of the incidence matrix. So there are three properties of the instance matrix, and those are the number of non-zero rows entires of row indicates degrees of the node, and the second one is the non-zero entries of the column represented by branch connections. And if two columns are same entries and then they are in the parallel. So these are the three properties of the instance matrix. So let me explain you once again. There are three properties of instance matrix. So one is the number of non-zero entries of row indicates degrees of the node, and the second one is the non-zero entries of the column represented by branch connections. And the third one is if two columns have same entries, then they are in parallel. So these are the three properties over here. So there is another called the reduced instance matrix. So firstly we have learned what is instance matrix, and now we'll learn about the reduced instance matrix. So the reduced instance matrix is formed by eliminating one of the row from instance matrix, generally ground node row is eliminating, which is represented by the A A A transpose. So the number of A inverse A transpose, or the number of possible trees of any graph, data of A transpose to the transpose. So once we form the incidence matrix, we can write the KCL equations of any complex without applying the KCL as follows. So the A inverse B equal to 0, whereas A inverse is reduced instance matrix. And the IB is a branch current matrix of any column matrix. So this is the reduced instance matrix. So we learn about the bus instance matrix. So the bus instance matrix by selecting the bus instance matrix is by selecting any one of the node of the connected graphs as a reference node. The corresponding column is deleted from A transpose to the obtain the bus instance matrix. The dimensions of A are E. So first one is the rank is n of minus 1. In the above example, selecting nodes as 0 as reference nodes. So the matrix A is obtained by the deleting the column corresponding to the node 0 as under. So it may observe that for the selected trees, say T1, 2, comma 3, the bus instance matrix can be so arranged that the branch elements occupy the top portion of the matrix A matrix, followed by the link elements. Then the matrix A can be the partition into two submatrix AB and A1 as shown, where I AB is one of the dimension B into B, the corresponding to the branches, and a second one is AI is of the dimension L into B corresponding to the links. A is a rectangular matrix, hence it is a singular. AB is non-singular square matrix of dimensions B. Since A gives the incidence of various elements on the nodes with their direction of incidence, the KCL for the node can be written as A transpose I equal to 0, where A transpose is a transpose of a matrix of A and I is a vector of branch currents. Similarly, for the branch voltages, we can write V equal to A, then bus equal to E. So the bus admittance matrix Y bus of for any n bus power system is square matrix of a system n into n. The diagonal elements represented the self or short circuited driving points. Admittance with respect to each bus, the of diagonals elements are the two circuit transfer admittance or the admittance commonly between any two number of buses. In the other word, the diagonal elements yii of the y bus is the total admittance value with respect to the ith bus, and yik is the value of the admittance that is present between ith and kth bus. So the fibers can be obtained by the following methods called the direct inspection method, and the second one is a step-by-step procedure, and the third one is singular transformation, and fourth one is a non-singular transformation. So the fibers, the admitted bus can be followed by this methods, like first one is a direct inspection method, and the second one is step-by-step procedure, and the third one is singular transformation, and the fourth one is non-singular transformation. So by the direct inspection method, the formulation of fibers is direct inspection method is suitable for the small size networks. In this method, the fibers matrix is developed simply by inspecting structures of the networks without developing any kind of equations. So next, the step-by-step method, we shall know use the method giving in the sections for the direct determination of Z-bus matrix without forming the fibers matrix. First, the accomplish this we shall consider the system of figure shall use the system data. Give an example. Note the first construction of Weber's matrix. We first eliminate all the voltage sources from the system. So thank you. So this is about the network topology and some information about the network topology, some Y admittance matrix and some matrices. So thank you.